Hey guys, in today's lesson we're going to go ahead and talk about the unit circle. How do we label it, its angles and coordinates and all that good stuff. So what I want you guys to do is to think about back in geometry when you learned about SOHCAHTOA. Okay, and actually you had two special right triangles, remember? Well, let's start off with this one right here. Okay, let's say this is a right triangle 45, 45, 90. Okay, now remember this is from the unit circle, so this is part of the circle. All right, this is 1 unit long. Okay, so 45, 45, that means these two sides are going to be equal because this is an isosceles triangle. So if opposite the 45 is this value, that means the same thing is going to be for this value. Okay, because they're the same angle. So what that means, you have A, and then you have 1. Okay, whatever this side is, this is going to be the same value. What you can do is apply the Pythagorean theorem. So A squared plus A squared equals 1 squared. Well, we can add these two because they have the same term, A squared. So 2A squared is equal to 1. Divide by 2, you get 1/2. Take the square root on both sides, you get square root of 1 over square root of 2, which is 1 over square root of 2. The only thing is you cannot leave it as a radical. You're going to have to rationalize. So you multiply the top and the bottom by radical 2, and then you end up with square root of 2 over 2. So that's how you got this here. And that's how we develop the special right triangle. Same thing with the 30, 60, 90. Now in geometry, you probably develop a method of, the relationship of special right triangles. For my students, I remember I tell them, this is 1 unit long, right? This is the hypotenuse. Well, remember the hypotenuse in a 30, 60, 90, the hypotenuse is always the longest side. The small side, the 30 degree, okay, this guy is always going to be half of the hypotenuse. So half of 1 is 1/2. If the hypotenuse was 10, then the 30 degree would be 5. If the hypotenuse was 8, then the 30 degree side would be 4. In this case, because it's a unit circle, this is 1 unit long, half of that is 1/2. What about the 60 degree angle? The 60 degree side, okay, here, all you're going to do is take this side, whatever value this guy is, and multiply it by radical 3. That's just the pattern that it applies. You would have to go back to geometry in order to apply it. And we're not going to do that right now. We're just going to take it at face value. But that's the pattern. So you have these two triangles, and these two triangles are used in the unit circle to find the measurements. Now, at first, when we're learning this, it's kind of difficult to understand at first, but once we get the hang of it, I'll show you guys how to find it quickly. So now that we have these two triangles solved, we can figure out the sine, cosine, and tangent of all these various angles. So for example, sine of 30 degrees, opposite over hypotenuse. Okay, 1/2 divided by 1, which is 1/2. Cosine of 30 is adjacent over hypotenuse, radical 3 over 2 over 1. Sine of 45, same thing, opposite over hypotenuse. All right, and that's where we get these values. What about tangent of 60? Tangent is, here's 60 degrees, so tangent is opposite over adjacent. So opposite to 60 is radical 3 over 2. Adjacent is 1/2. So we would have radical 3 over 2 divided by 1/2. And you notice how they both have a 2 on the bottom? I can just kind of cancel those out, and you're left with radical 3 over 1 or radical 3. Now, if that doesn't make any sense, all I did was the division algorithm. I take the top divided by the bottom, you keep it, change it to multiplication, and you do the reciprocal of the second fraction. Notice that the 2's simplify out, you're left with radical 3. Okay, that's where we basically get it. And what we're going to be learning is how to solve these guys, okay? And there's actually a pattern for that. So with that, I'm going to actually use the unit circle, okay? And I'm going to show you how to kind of fill it out, okay? So first things first, let's do it in degrees. So this is 0 degrees, okay, and then also 360 degrees, all right? And let's label the points first here. So on this side, you have 1, 0. Okay, on the left side, we have -1, 0. On the top, up here, you have 0, comma 1. On the bottom over here, you have 0, comma -1 because it's all 1 unit long. So that's pretty easy. All right, well, this is 0 degrees. Well, how much is this guy here? And if you notice, that's a 90-degree angle. So that's pretty simple. All right, on the other side over here, well, half of a circle is 180 degrees. Cool, that's simple. And then we notice all the way around is 360. We already got that guy. Well, what is halfway between 0 and 90? Would be this guy, which would be 45 degrees. Okay, cool. And remember, we talked about the special triangles 30, 60, 90. That's what these are. So this guy first here is 30. Okay, and the next one is 60. And essentially what you're doing is you're counting by 30 all the way around, except for the middle angle. So 30 plus another 30 is 60, plus another 30 is 90, plus another 30 is 120. Don't count the middle. Plus another 30 is 150. Plus another 30 is 180. Plus another 30 is 210. Plus another 30 is 240. Plus another 30 is 270. Plus another 30 is 300 degrees. Plus another 30 would be up here, would be 330. And then lastly, plus another 30 would be 360. So that makes sense. Now, what about the 45? What about the middle? Well, all we're doing is adding by 45. 45 plus another 45 is 90. Or what you can do is just add 15 degrees to the one previous. So 120 plus 15 is 135. Okay. 210 plus 15 is 225. Actually 300 plus 15 is 315 degrees. All right. Now at first it is kind of difficult, but if you understand how to build it, it's okay. You can construct the unit circle. All right. So we have all our degrees. Okay. Now we need our radians, because remember in trigonometry we use radians. Okay, and this is the fun part and it's the easy part. Remember 30 degrees, hopefully you learn that is pi over 6. Okay, what about this guy? 45 degrees, hopefully if you've been able to do it, you should get pi over 4. And then 60 degrees is pi over 3. Now essentially that's all you need. All you need is this first quadrant, and you can fill in everything else using addition. How do you do that? Well, in order to get the second quadrant, all you're going to do is, the beauty of a circle is that it's symmetrical. It's like a mirror. So watch what I do. 3 take away 1, 3, and there's an invisible 1. 3 take away 1 is 2. So this guy over here to the left is 2 pi over 3. This guy here in the middle correlates with the middle one here. 4 take away 1 is 3. So this is 3 pi over 4. 6 take away 1 is 5. 5 pi over 6. Okay? And that's it. What about the ones in the bottom? Well, the ones in the bottom, what you're going to be doing is adding. So 3 plus 1, you're going to follow it. Okay, all the way. 3 plus 1. Over here is going to give you 4. 3 plus 1 is 4. 4 pi over 3. The middle, 4 plus 1 is 5. So it's going to be 5 pi over 4. 6 plus 1 is 7. So that'll be 7 pi over 6. Okay. What about this one over here? Same thing. 3 plus 2, follow it all the way. That's going to give you 5 pi over 3. 3 plus 4, 7 pi over 4. And the last one, 5 plus 6 is going to give you 11 pi over 6. And that's it. Those are all your radians. Okay? So notice, all you need to remember is the first quadrant. To get to the second quadrant, you're subtracting. Okay? 3 take away 1. 4 take away 1. 6 take away 1. To get across, okay, you're adding. Okay? 4 plus 1, 5 pi. 6 plus 1, 7 pi. 3 plus 1, 4 pi. You just got to make sure you follow it correctly. Okay? And that's pretty much it. Oh, you know what? What we did forget was this guy. 90 degrees is actually pi over 2. Well, 2 plus 1 is 3. 3 pi over 2. There you go. This guy over here, you guys know half of a circle is 1 pi. Full going around a circle is 2 pi. Now, what about this guy over here? Actually, they just an extra circle, but an extra label, but it's actually 0 pi, which doesn't really matter. So we're almost there. Good. Now, what about these coordinates over here? That's where the 30, 60, 90 triangles come into play. Now, check it out, which is pretty cool and pretty simple. The beauty of this is they're all in the bottom. It's all 2, 2, 2, 2, 2, 2, which is nice. They all have a square root. Okay. Well, actually, let's do this first. From top to bottom. 1, 2, 3. Notice how I did that? From top to bottom. And then we go back up. 1, 2, 3. And then on the top, they all have a square root. But the square root of 1 is 1, so I'm just going to leave it. So this guy's square root, square root, square root, square root. And the square root of 1 is 1. And these are the coordinates for these radian angles using sine, cosine values. Because remember, this first one, we don't call it x anymore. We call it cosine. The second one, we call it sine. But that's how you fill it out. Well, how do you fill out the other ones? Same thing. These points are exactly the same as over here. The only difference is whether it's positive or negative. So this guy is exactly the same over here. So we're going to have 1/2 radical 3 over 2. The only difference is because we're going left, the x is going to be negative. This guy's negative. What about this guy? Same thing over here. Radical 2 over 2. Radical 2 over 2. The only difference is because we're going left, right? It's negative, right? In order to get to this point, you got to go left and then you got to go up. We're going up is positive, but because we go left is negative. The x coordinate, you can say. What about this guy? Same thing. Radical 3 over 2 and then 1/2. The only thing is this guy is the x is negative. All right? Beautiful. Now, what about this? These guys are exactly like these guys. Exactly, okay? Or if you want to follow it down along this line, either way. So this guy, you move it all the way down, same thing. Okay? So I think, let me see here. I'll start off with this guy here. This guy followed along, same exact coordinate. Radical 3 over 2 and then 1/2. The only difference is now negative to the left and it's going down, so they're both negative. What about the middle? Same thing as the middle over here. Radical 2 over 2, radical 2 over 2. Left negative, down negative. So these guys are both negative. And the last one is this guy here. Okay, follow it all the way down. Same thing, it's going to be 1/2 and then radical 3 over 2. And same thing, they're both negative. All right. Last one, and we're going to go ahead and do this side. Same thing. The middle, if you notice, the middle is always square root of 2 over 2. And that's probably the easiest one. But we go to the right, positive, and then we go down, negative. So the first one is positive, the second one is negative. Okay. And then what about this guy here? Follow it down here. Same thing. That's going to give you 1/2. And then radical 3 over 2. We go to the right, positive. We go down, negative. So the second one is negative. And then the last one over here, same thing, okay? We do it, radical 3. We follow it here, radical 3 over 2, and then 1/2. Same thing, positive, and then negative. So positive here, and then negative there. And, man, that's it. We filled in the whole unit circle. That's how you fill in the unit circle. Now, I'm going to show you guys how to figure out how to solve these, because I will be asking what's the sine of this, sine of that, cosine, all this stuff. So watch this. Use your hand, and this is the x-axis, this is the y-axis, and this is your 30 degree, this is your 45, this is your 60, okay? So let's say I wanted to find out, remember how we said sine of 30? Okay. Let's do sine of 30. Here's 30 degrees, you fold it. Sine, okay, the top fingers of your bent finger, the top represents cosine. The bottom represents sine, okay? So if I bend 30 degrees, what's the sign? The sign is this guy, one finger. So the answer is 1 over 2. Sine of 30 degrees, 1 over 2. There it is. Cosine, sine. Okay? So remember, this guy is no longer called x. We call it cosine of theta. And the second one, normally we call it y. We don't call it y in trig anymore. We call it sine. Okay, what about cosine of 45? 45 is the middle. You bend it. Cosine is the top fingers. So 2, square root of 2 over 2. And there it is. Okay. And then what about tangent? Okay, well, tangent, let's say do tangent of, what do we do, 60 degrees? 60 degrees is this guy. Tangent is sine over cosine. Sine is 1, 2, 3, square root of 3 over 1. Square root of 3 over square root of 1. Square root of 3 over 1 is square root of 3. And you see how I did that? Now, that goes for all of them all around. The only difference is they're going to be positive and negative. All right? And for us over here, okay, right here we say all. Okay, all the trig ratios are positive. Sine, cosine, tangent. Over here, I'll just put sine. Okay. All sine is the only one that's positive in this quadrant, quadrant 2. Okay. Quadrant 3 is tangent. Tangent is the only one that's positive. And then the last one over here, quadrant 4, is cosine. Okay. And then some students come up with an acronym, all sin tacos, or all students take calculus or something like that. But hopefully that helps out, guys. Practice the mnemonic, practice, filling in the unit circle, and the more you do it, the more you use it, the easier it'll get. And hopefully that helps, guys, and I'll see you guys next time.